Hi there, this is Ajit. Welcome to Step by Step Data Science tutorial. So we are in part 7. We will discuss today about neural network and why do we use neural network, feed-forward propagation concept, and we will implement all this from scratch in Jupyter Notebook. So let's start. What is neural network? Neural network is inspired from how a human brain works and is used to represent complex non-linear hypotheses. So you might be wondering what is complex and nonlinear hypothesis. So let's give an example. So in last video, we discussed about multi-class classification where we have three classes. That's why it is called multi-class. So let's say my classes, three classes are, so this is cloudy. Let's say we predict a weather as cloudy, sunny, and rainy. So what we did was we we used one versus all concept and we plotted our decision boundary over here where my this class represents cloudy and these two represents sunny plus rainy. So this was what we did and we called it as one versus all concept. So similar concept we use in neural networks. So let's say if we have three input x1, x2, x3, and we applied our activation function. So here we have used sigmoid as activation function. So in neural network terminology, we use a function called activation function. What does this mean is which function we are applying to our neuron that will give us the predicted output. So here we have applied sigmoid function. So in neural network terminology, we called it as activation function being sigmoid. So the simple concept lies over here. This is our output, this is our input, and we predict our hypothesis. So here what would be our hypothesis? It would be, so let's say if this is our theta 0, theta 1, and theta 2. So what would be our equation? It would be x1 theta naught plus x2 theta 1 plus x3 theta 3. And if we take the g of this value, we get h of theta. So similar concept lies in neural network. Here in neural network we say this as my input unit. So this is my input unit. So we have three input unit 1 2 3. So here we have three input unit and this is my output unit. This is what we called output unit, and here this is my computational unit, and this is also called, this whole structure is called single neuron, one neuron, because our output is one, so that's why it's called one neuron architecture. So this is my one input layer and one output layer. That's what we call in neural network. So likewise, let's say if I have a three-layer network. So why it is called three-layer network? Because this one is called input layer. This is my first layer, and this is my hidden layer. So whatever lies between input and output layer is called hidden layer. So this is my hidden layer. So this is my second layer, and this is my output layer, and this gives me h theta of x. Here like I said, this is my unit, input unit. We say input unit. So this is my activation function, a1 a1. So here a1 2 means this is my second layer first unit. That's how we read this a1. Likewise for a22, this is called second layer second unit. Sorry, this is second unit. This is how we read this. So here we have three neurons. So what is neuron? Neuron is the computational unit which takes input and gives output. So here in this example we have three neurons, and so our x is x naught, x1, x2 in terms of vector multiplication. So our theta is theta naught, theta 1, theta 2. So we need to include one bias term, theta naught, that maps all my activation function. So this is called bias unit. And then we have activation function A in terms of matrix. We write it in this way. So here again we have another bias term which maps to this output. So this is what we call input parameter. Previously in neural network we even call this as weight. So we need to be very careful with this terminology because people usually call this input parameter as weight. So in how many layers of neural network we have? If someone asks with you, then here we can say we have three layers of neural network. One is input, one is hidden, and one is output. How many units we have in one layer? So we have three units in one layer. So how many neurons we have in our architecture? So we have three neurons, and we have three neurons, three units of input layer and one output layer. So we need to be familiar with these terminologies. So let's say, so like I said, this is my input unit. So it comes from similar concept of that what we did for multi-class classification. So x1, x2, x3 is my input layer, and I apply my activation function sigmoid function, which in neural network we call it as our activation function, and we calculate our output unit. So likewise, let's say if we have a three input unit. So this is x1, x2, x3. So this is my three input unit. This is my first layer. Okay. And then we have a second activation function, a1, this unit. This is my second layer, second unit. This is my second layer, third unit. And this is finally my theta of x. So in this we can even denote this as my a0 layer first unit. This is a0 layer second unit. This is a0 layer third unit. So how we compute a1 of second layer is, this is my theta of 10 x naught, which is connected with this. So this is my bias term plus theta of 1 So this is my 1 theta of 1 and this is again, this is my x1 of first layer plus theta of 2 of first layer of x2 plus theta of first first layer of third output x3. So this is the same thing, like this is is similar to applying a linear regression where my y was theta naught x naught plus theta naught plus theta 1 x1 up to theta 4 x4, and then we take a g of this and then apply 1 by 1 plus e to the power minus g, and my g is this term is g. So this is similar way of writing in this term, because we have theta in our more than three-dimensional shape, two-dimensional shape. That's why we give a term like 1 1 to represent this line, 1 2 to represent another line. That's why we write it in this way. And again, so my a of second layer of second unit, so this is my second layer second unit. This will again be my theta of, this will be second of my first layer of x naught plus theta of 2 1 second layer. That's why it's second layer here of 2 2. No, sorry, so it is 1 x1 plus theta 2 2 of first layer x2 plus theta 2 3 of first layer x3. Likewise, my a3 will be, 3 of second layer will be theta of 3 0 of 1 of x naught plus theta of 3 0 3 1 of 1 of x1 plus theta of 3 2 of 1 of x2 plus theta of 3 3 of 1 of x3. This is how we compute a3. Now a1 a2 and a3 become an input for my final output variable. So this is first layer, this is second layer, this is my final output layer. So so a1 of third layer, so this is my third layer. So third layer of first unit will be theta of 1 0 of second layer. Again, this is my bias term, this is my bias term here, a0 of second, which will be there, plus of theta 1 1 of second layer of a1 of 2 plus theta 1 2 of second layer a2 of 2 plus theta 1 3 of second layer a3 of 3. So here this one, this and this and this is calculated from here. So whatever the output of my second layer becomes the input of my third layer. Okay, so in vector terminology, in vector way of representation, what we can do is we can even write a2 of 1 as z of z1 of 2, because how we can write this is because we know that our output, this, if we take g of this or all these with this in this way in vector notation. Likewise for a2, even we can denote that into g2 of 2 and so on. So my final hypothesis h theta of x will be g of z1 of third. So this will be my final output. Hope this makes sense, because this is what we did while implementing in logistic regression. We computed all the x naught till x3 and then calculated our g value, sigmoid function. We applied sigmoid function. That's what we are doing here. But the difference is the output of second layer becomes input of third layer. We need to keep that in our mind. So therefore my x becomes, in terms of vector notation, becomes x0, x1, x2, and my z of 2 becomes, the vector notification becomes z1 of 2, z2 of 2, z3 of 2, so on. So finally my z of 2 becomes theta of 1 of x, and where x can even be denoted by a1. So this is what theta of 1 is what we did for my first layer. It is 1 0 plus theta of 1 1 for first layer plus theta of 1 2 of first layer plus theta of 1 3 of first layer is denoted by theta of 1 in vector term, and my x is the input layer, which is x0, x1 and x2, and my a2 becomes again z of 2. So my final h of theta becomes, h theta of x is a of 3, which is my z of 3. So this process is what we call a feed-forward propagation. So this is how we compute from input value to output value. So this is called feed-forward propagation algorithm. So where we compute from first layer input to output. So this whole process of computing the output, calculating the activation function, and finally generating the output is called feed-forward propagation algorithm. Now what we will be doing is we will be implementing this in Jupyter Notebook. So this is my library. This is the same dataset that I have used from Andrew and Coursera dataset. So this is the same. This visualization is same that I did for last time. So now we have our weights. So weight is given for us. So what is given is, now weight is given. So my theta is given, theta 1 and theta 2 is given. So my theta becomes theta 1, theta 2, theta naught, one biased term we will add, and again for x my will become x naught, x1, x2. We will add this biased term. So right now in data we have theta 1 and theta 2. So I appended 1 to include bias term over in my x variable. So now let's create a class to implement feed-forward propagation. So my class name will be feedforward underscore nn. I will pull my classes from logistic regression because I need to use sigmoid function of my logistic regression. So I will pull this class in my main class. So this is the inheritance concept. I hope you all know that. This is just to initialize my class. Let's write a function. when my input parameter theta1 and theta2 is given. So what we did in first was, first we compute a1. So a1 means, let's say my, so first we compute a1. So a1 here is this. So we will compute first a1, and then we will apply g this, and we will apply this sigmoid function we will apply, and then we will get output for a1. So let's write that. So my a1 will be my x. I have already included a bias term over there, so by including x naught. So this, I have already written a function that opens 1 in, so bias term is already been added. So I will do dot product of theta1. I need to transpose here to match the shape, and then I will calculate my g, and this will be dot sigmoid of a1. So what we did right now is we calculated a1, and then we computed g of, we applied sigmoid function there, and then we will again add one bias term. Let's say h naught is my bias term, h naught of 1s. Let's append this bias term. Axis value 1. Now what we will do is, the output of this becomes input for my third layer. So now we will implement this. Now we will calculate this, which is the combination of this. So my a2 will be again z1 of theta2. So z1 is again my input. Cross transpose, and then again I will apply my sigmoid function. So whatever I will get here will be my final output. So I will return z2. So this is working fine. So for prediction, again we will take max of whatever output we have got. So it's similar to what we did in multi-class classification, and this is my output. So why did we use a neural network instead of multi-class classification is, the neural network is designed to handle non-linear complex hypothesis. So this non-linear complex hypothesis is designed for neural network. For logistic regression, if our output is like binary classification, or three output we have, or three classes we have, then we go for logistic regression. But if we have more than three or four classes, like for example, here we have handwritten digit where we have 10 classes, 20 output. So if we have more classes, then we would prefer to use neural network instead of logistic regression. So neural network is designed to handle multiple classes, and if we have more. So if you like my video, please subscribe and like my channel. and see you next time. Thank you so much.